Imagine a transparent tank filled only with liquid, no nozzles, no filaments, no cutters. And within moments, without any physical contact, a detailed 3D model begins to emerge from inside that liquid. This isn't a magic trick. This is stereolithography, or SLA, a technology that uses light to create 3D objects. In the first part of this video, we will explore the working of SLA through full animation. We'll cover the UV laser path, resin solidification, platform movement, the leveling blade, and the final curing process. Then in the second part, we will break down this process into a simple, exam-friendly diagram, so you can write a perfect answer for your theory papers. Let's understand the working through animation first. First, the 3D CAD model is loaded into slicing software. The software divides the model into many thin horizontal layers, just like thin slices of bread. Each slice is a 2D cross-section. These cross-sections tell the SLA machine exactly which path the laser must follow at every step. Now focus on the liquid resin tank. This vat is filled with photosensitive polymer resin. Its nature is unique. Wherever UV light hits it, it turns from a liquid into a solid. A side-mounted UV laser source generates a thin, highly focused beam. This beam reflects off mirrors and lenses to reach the surface of the resin. The laser receives commands from the software and starts tracing the 2D pattern of the current layer onto the resin surface. As the laser moves, wherever the beam touches the resin, a chemical reaction begins, and that region becomes a solid polymer. The rest of the resin that wasn't touched by the laser remains liquid inside the vat. You can remember this step with one word: solidify. Now imagine a thin solid layer has been formed just below the surface, but the liquid resin on top might be slightly uneven. This is where the leveling blade comes in. This straight blade moves across the resin surface from one side to the other. It pushes the liquid resin ahead like a small wave, leaving behind a perfectly flat, smooth, and uniform liquid layer. Its role is to prepare a perfectly level surface for the next layer. After leveling, we move to the build platform step. The Z-axis motor lowers the build platform by exactly one layer's thickness. In typical SLA machines, this thickness is approximately 0.05 to 0.07 millimeters. That's thinner than a human hair. The platform moves down just enough to create space for a fresh, thin layer of liquid resin over the previous solid layer. The liquid inside the vat flows over the surface automatically, creating a new thin liquid layer. Now the UV laser starts its work again. It traces the next 2D cross-section. Wherever the beam passes, the new resin solidifies and bonds strongly with the layer below it. Now the height of your part is 2 layers, then 3, 4, 5. The cycle continues. Follow, solidify, smooth, lower. If you remember these 4 words, you will always remember the core working of SLA. This cycle repeats hundreds, sometimes thousands of times, and slowly the complete 3D model grows from bottom to top. When the last layer is finished, the software declares the build complete. The Z-axis mechanism elevates the build platform. Your solid 3D part emerges from the liquid resin tank. It stays above the vat for a while, allowing extra liquid resin to drip back into the container. After draining, some uncured resin might still be sticking to the surface. To remove this, the part is rinsed in a cleaning solution like isopropyl alcohol. After cleaning, the part is placed in a UV curing chamber, where extra UV light is applied to finish the polymerization completely, making the material stronger and stable. During printing, support structures are also built to hold overhangs in complex shapes. After the final cure, these supports are removed and any marks are smoothed out through sanding or polishing. In this animation, you saw the full cycle. Now let's look at this process from an exam point of view using a simple diagram. Part 2, Diagram and Exam Explanation. Suppose you get this question in an exam. Explain the working of stereolithography with a neat sketch. To score full marks, you can draw a basic diagram with these labels: resin vat, liquid photopolymer, build platform, part being built, UV laser, mirror or galvo, and the leveling blade. For the written part, explain it in these 6 clear steps. 1. CAD model and slicing. 2. Resin vat and build platform setup. 3. Laser scanning and solidification. 4. Leveling blade action. 5. Platform lowering for the next layer. 6. Post-processing, including rinsing and UV curing. In the practical world, SLA is used where accuracy and surface finish are critical, like dental models, jewelry patterns, and high-detail engineering prototypes. To recap, SLA uses liquid photosensitive resin. A UV laser traces the pattern. The resin solidifies. The blade smooths the surface. The platform lowers, and the cycle repeats. If you found this explanation helpful, please like the video and subscribe to the channel for more engineering topics simplified. Thank you for watching.